In an ideal situation, the U.S. government would be positioned at this time to restructure an old and illegal trade embargo against its citizens, so as to allow retail sale of clean energy from residential production to local manufacturers. As many crises as this would avert, that correction is unlikely anytime soon. Regardless of any new product established here, this should help sales significantly, with just a small amount of legal homework applied to the specific region in question concerning the local utility cogeneration law, as applied to total amount allowed to be sent to the grid before required sale at wholesale prices. That is the loophole. Most of the utility companies, in the U.S. anyway, have been required because of the increased cost of a bureaucratic process to establish a one-year accounting method that will tabulate the balance of a residential generation source only once a year, usually in January. Farmers, first in the U.S., are in a particular situation to take advantage of this. We are in a prime opportunity to make a substantial difference with this, to explode the U.S. economy, climate, and thus the rest of the world by just using some scrap that we normally toss. The flip side of this is it may be the only time a company of this size will have the opportunity to position such a structural point of leverage in the developing energy market.
The calving face is 300, sometimes 400 feet tall. Pieces of ice were shooting up out of the ocean 600 feet and then falling. The only way that you can really try to put it into scale with human reference is if you imagine Manhattan. And all of a sudden, all of those buildings just start to rumble and quake and peel off and just fall over and roll around. This whole massive city just breaking apart in front of your eyes. We're just observers, these two little dots on the side of the mountain. And we watched and recorded the largest witness calving event ever caught on tape.
So how big was this calving event that we just looked at? We'll resort to some illustrations again to give you a sense of scale. The height of it is equivalent to buildings that are 2.5 or 3 times higher than they are. In 2000 to 2010, it retreated 9 miles, so in 10 years, it retreated more than it had in the previous 100.
Essentially, a small farmer pumps electricity into the grid flywheel all spring and summer long, then uses it in the fall in a 1 week to 1 month period to dry the crops for longer storage and better prices of bulk grain. As stated, current solar can be used, but wind is a much lower startup cost, and with correct engineering can pay for itself in the first year, with potential for yearly repeat sales to each customer. This is particularly applicable to lower income farms in developing countries. This preserves the land for the farmer as opposed to unneeded fracking, in that the current natural gas and the amounts similar to those gained from fracking used in drying grain now would be replaced by electrical power. It is a benefit for the utility companies also, in that it allows for lower investment in generation equipment and fuel, with a low use period in the summer for inspection and maintenance of said equipment, with a high use period in the fall to test the equipment and grid before the winter peaks happen, usually when repair is ungainly. We can sell quite a few farms solar installations for future economic development. However, the windmill on the farm is a very iconic potential for sales boost. The reasons people prefer solar to wind are mostly twofold. One, maintenance, and two, damage susceptibility. There are not a lot of family farmers interested in renting a cage lift every year to service the generator assembly on the top of a 20 to 40 foot mast, or repairing said generator assembly in storm conditions 40 feet up in the wind. So I developed a fold-down, counterweighted mast assembly that can be lowered to service the generator assembly on the ground and be retracted in storm or high wind conditions to reduce damage, to allow for more efficient blades that operate better in more consistent lower wind conditions. To be an icon presentation, able to use the same inverter components as the installed solar panels when the sun isn't shining, for farmers that just like that kind of thing. To reduce costs, both manufacturing and shipping, what I would do is have the customer supply the cement and primary mast from a local supplier, then just supply the mounting components, the wiring, and panel to connect the generator to the inverter or DC load as required. The parts we would provide are so insignificant as that they can be provided from mostly drop of the solar panel TPM assemblies from any large drop size, and potentially be given away with the purchase of said TPM components. The first part of this animation shows what the parts are made from, with the approximate size, and how the parts go together. Engineering results notwithstanding, the primary mast is made from 3x3 by 0.18 square tube. The second part of these animations shows how the farmer-customer constructs the system. The 3x3 tube sets into the lower assembly of the two welded sections. One of these tube assemblies is set into a rebar reinforced concrete with a panel box attached to it for connection to the grid or storage wiring. The other used as a retainer for concrete filled counterweight. Pre-drilled holes locate the position of the drill points for the pivot on the 3x3 tube, as well as the lower anchor and release. The third animation and clip examples show the operation of the system in place, along with multiple units application. The lower cost of these 2 to 5 horsepower individual units allows for the addition of singular units at the customer's leisure or economics to form other compatible function structures. In other words, power line support for property use, fence support for animal containment, wind deflection for efficiency increase to the blade area as some examples. Since the generator can be lowered, a shock stop should be an option for later sales, along with a second option, the preset auto release to lower the generator at a specific harmful wind speed condition aligned to the prevailing winds of the area. The mast is then set back into place by any motorized vehicle with a cable attachment. The size and complexity of such an operation can be estimated by the video of the 10 horsepower system being constructed. There are other things that these smaller system assemblies can be used for. The customer will not have to use it specifically as a tested wind turbine generator mount. It can be used as a test platform for a warranted 100,000 mile automobile alternator conversion, a hydraulic or mechanical pump for water with mechanical connections inside the tube, a yard light that can be lowered for use as a close proximity work light, an enclosure area access gate, a flagpole, a windsock, a beacon light, a radio tower base, or any or all the combinations of the above.
I think it's going to become probably one of the largest growing, fastest growing industry sectors in India. And I see this spilling to our neighboring countries like Pakistan, Bangladesh, Nepal, Sri Lanka. All of
this is an advantage for the society, a big advantage. It is the way from a monopolistic structure to a broad ownership, to an energy supplying system with many self-producing, self-production structures, and decentralized.
In developing this farmers market, it would be a friendly token of support to show the attitude and responsibility of the company to this significant emerging market base, since it is such a useful and iconic addition to the smaller farms worldwide.